Welcome students to experimental design. Experimental design, basically we are carrying over from the work that we did when we were looking at how to write a research proposal. And in most cases when you do research, at some point you need to collect data. So the data that you collect is the one that will help you to address your objectives, the objectives of your study. So experimental design is another way that can be used, or in fact it is a class of study. When we say a study follows an experimental design process, it means that as part of your work to try and address the objectives, you need to lay down an experiment. Either the experiment can be in a field, in the laboratory, or in any other suitable places, or in a greenhouse or so forth. So what we are going to be doing in this preliminary video is actually to introduce such studies which we call experimental design studies. Now what is an experimental design? When we talk of an experimental design, we are looking at tests or a series of tests which purposefully changes are made to input. So the input is what we refer to as the independent variables of a process or a system, so that we can observe or identify the reasons for changes that may be taking place in the output, which we refer to as the dependent variables. So it can be one dependent variable or a set of dependent variables. Now I want you to take note that when we say purposefully, a researcher normally makes a hypothesis that there is a strong belief perhaps that a different planting dates for a particular crop will result in different yields. So the planting dates can be manipulated. That is why we are saying you purposefully, instead of planting in a certain day, maybe you start planting on the 15th of November. So it is purposefully done in order to investigate the effect that planting date will have on the dependent variable, which could be then yield or any other such variables that could be measured. So experimental design can also be considered as a planned inquiry. You need to plan. So if you want to carry an experiment and you don't plan, make sure you are assured of failing already from the onset. So experimental design studies involves tests or a series of tests. It can be a number of such tests in which we make some changes to independent variables. We are going to define independent variables and try to make it very clear to you, and so that you can picture in your day-to-day lives. So experimental design can be used so that the treatments may be assigned in an organized manner. I want us to underline the term treatment, and I want us to understand the meaning of treatment in the context of experimental design. Now, different designs isolate different known or suspected sources of variation so that the treatment effects can be evaluated free of extraneous environment. All these terms that I'm underlining, please make sure you understand their meaning clearly. So statistical theory also requires that certain conditions be met during the execution of experiments to permit valid probability statements to be made. So we are going, of course, to look at what are those statements that must be, or conditions that must be met. So I'm sure at this time we have some new terms that we've introduced, perhaps, which we need to appreciate their meaning. So I'm going to look at the definition of these terms one by one. What do we call a treatment? In most cases, when we are not feeling well, we go to the hospital, and when we go to the hospital, when we come back, we say we've received treatment, or no treatment was given to me. So the same way we use the term treatment to refer to perhaps some medication, which could be some pills or whatever that you are given when you go to the hospital, it is the same way that we use the term treatment in the context of an experiment. What is a treatment? It is the level or class of a factor whose effects are to be investigated. Is the level or class of a factor whose effects are to be investigated. So an example here might assist you to understand what we are talking about. The previous example, when I mentioned about you going to the hospital, when you are not feeling well, you are given maybe Panadol or whatever tablets that you are given. So we want to see how those tablets will have an effect on the disease that you are suffering from. Now, if you had a certain ailment, maybe headache or so forth, and you go to the hospital, you are given an injection. It is a treatment in the sense that we want to see the impact that an injection or the tablet will have on the current disease that you are suffering from. The doctor would actually say, okay, come for review. So why you go for review is simply to say the treatment that has been given to you, now the doctor wants to see the impact that the treatment has had on what you were suffering from, which could be measured perhaps by taking your temperature and asking you a couple of questions. How do you feel? Are you now able to eat, and so forth? Now let's come back to the context of treatment in the field of experimentation. We might suspect that different spacing, for example, of a particular crop will produce different yields. So in short, spacing, we know that will affect the plant density. That is the number of plants in a given unit area. So a researcher can then go on to plant crops using different spacing dimensions and record the yield under each spacing dimension. So the spacing in that case now will be referred to as a treatment or an independent variable. It is an independent variable because nothing is affecting spacing, but we expect spacing to have an impact on a number of parameters or dependent variables that the researcher will measure. Now let's look at an experimental unit. What is an experimental unit? An experimental unit is simply defined as the smallest experimental material upon which a treatment is applied. You see, when you go to the hospital, in the previous example that I've given you, the treatment in this case could be tablets or the pills that you are given, or an injection, or whatever that the medical officer would deem fit. You who is receiving the treatment, you are referred to as an experimental unit. So the experimental unit is the smallest experimental material upon which a treatment is applied. The unit that is receiving the treatment is called an experimental unit. Now, the response or dependent variable is that characteristic of the experimental unit which is measured. That is what we call the response. For example, when you are getting tablets, we expect your temperature to normalize. If your temperature was now 40 degrees, we expect it to come back to normal. I don't know what the normal temperature is, whether is it 36 or so, but if your temperature was high, we expect it to come down to a certain level. And when we are now measuring or checking your temperature, that is a response variable. As a result, the variable is responding to the treatment that has been administered. So in the previous example that I've given you for the field experiment involving spacing, the response or dependent variable could be yield. How will yield respond to different planting density? So now, but what is a factor? A factor of an experiment is controlled independent variable, a variable whose levels are set by the experimenter. A variable whose levels are set by the experimenter. I want you to take note of the differences between a treatment and a factor. So within a factor, we may have levels. For example, when we say temperature, temperature is a factor. But within temperature, we may set different temperature levels, and we want to investigate the effects of different levels of temperature. For example, we may have 30 degrees, 40 degrees, 50 degrees, and so forth, and maybe we want to determine the effect of different temperatures on germination of a particular seed or crop. So in that case, now you would realize that the different levels are the treatments, and these levels are within a factor. So temperature is the factor. The different levels within temperature is what we refer to as treatment. Now, this is just a summary to show you the different meanings of terms as used in experimental design. So we have an experiment which I've summarized as a planned inquiry, and then treatment procedure whose effect will be measured. So we want to see how a treatment will affect. So we want to see the effect of a treatment on a dependent variable. Now, factor, class of related treatments. Like the example that I've given you, temperature, it is actually a class. So within a temperature, we may have different levels. Now, levels is actually the states of a factor. See, we can ask, what is the temperature? When we ask what is the temperature, we are actually saying we want a specific figure to show us the state of temperature. Now, what is a variable? Variable comes from the word vary. To vary is to change. When we say something varies, it means it changes. So a variable is a measurable characteristic. It is a measurable characteristic. And I want you to take note, in the context of an experiment, we can have a dependent variable. Now, that which will change in response to the treatment. But we may also have an independent variable, that which will be fixed, and we allow the other variable now to float, so that we can see how is the variable which is allowed to change is responding to the variable which has been fixed. So what is an experimental unity? Unity to which a treatment is applied. This one I have already given you this, and I'm just summarizing the definitions. Now we have also a term replication. Of course, we are going to go into detail in the next video, where we are going to look at the principles of experimental design. So what is replications? This is actually repetitions, repeating. Experimental units that receive the same treatments, we call them replications. But I'm going to put this one into more context as we proceed. Now, what is a sampling unit? Part of experimental unity that is measured. It is called a sampling unit. What about a block? Group of homogeneous experimental units. I don't want you to be, discouraged. You are going to realize how simple these terms are as we move on and as we give more examples to try and put all these terms into context. Experimental error, variation among experimental units that are treated alike. You see, when we plant same variety, maybe maize variety, we expect yield to be the same across one plant to the other. But that is not the case. In most cases, you do realize that the yield of this plant is different from the yield of that one, which is different from the yield of that one, and so forth. So when we see variation among experimental units, which are almost treated alike, we say that is actually error. That is what we call experimental error. Now, why do we conduct experiments? One would ask. Ladies and gentlemen, in the current period where we are battling with COVID, the world over, they are involved in so many experiments to try and answer the question, what works? We are looking for treatment to the pandemic, but that treatment does not come without carrying some experiments. Recently, if I'm not mistaken, I saw in the newspaper where a certain figure was given that the government needs so much amount in order to recruit people who are going to be tested for the subjected to the new developed treatment for COVID-19. So that is an experiment. Experiments does not imply the usual laboratory, the only laboratory experiments that you normally talked of when you were doing your high school, where you need to put on a lab coat and you go in the laboratory or so forth. Experiments vary in so many ways. It can be in a field where farmers can manipulate certain things to do with their crops and then try to see what will happen. So experiments are conducted in order to explore new technologies, new crops, new areas of production, and so forth. So we can talk of experimental design in environmental science, in agriculture, in industry. You see, most successful industries are those that are involved in a number of experiments. So industrial revolution coincided basically with a lot of advances in technology. And we can't talk of an advancement in technology if we don't bring in the concept of experimentation. So experiments are also conducted to develop a basic understanding of the factors that control production. Most companies they have a section for research and development. And in those sections, there are a number of experiments that are conducted in order to see what are the factors that promote highest production. So if a company does not have research, research and innovation section or so, such companies usually they end up using outdated technologies and so forth, most of which they may be booted out of the market. We know of so many companies that made headlines, but as we speak today, they are nowhere to be found simply because they could not do enough research. I'm sure even in the cell phone industry, we know how Motorola made headlines when they came, but today, I don't know if Motorola is still in existence, but we can see that where they started, we were able to communicate. But now came the period of smartphones and so forth, which can do a lot more. So experiments are conducted in order to develop new technologies that are superior to existing technologies. We are talking of 5G. So a lot of, now there is an experiment going on, artificial intelligence, where computers will just be told what to do. Currently, we are giving instructions ourselves, but we are told a phase is coming when computers will be told, will just be told what to do, and they do. That is maybe artificial intelligence, so forth. That is the part of experimentation. We also do experiment to study the effects of changes in the factors of production and to identify optimum levels. We also do experiments to demonstrate new knowledge to growers and get feedback from end users about the acceptability of new technologies. So I want us to look at some types of field experiments. Now, these field experiments are oriented towards applied research. So we have agronomic trials. So these are, I've tried here to list a couple of agronomic trials. So I want you to appreciate the application of experimental design. We can do fertilizer studies where we can develop new fertilizers, and we want to see how those new fertilizers affect fertility first in the soil, and eventually how do crops, certain classes of crops, respond to those different fertilizers. So we call those fertilizer studies. So we can have time, rate, and density of planting. I've already given you an example. The timing of planting is critical. We don't just plant crops all year round, but there are specific times where a certain type of crop performs best. So we can also have the rate and the density of planting. Density of planting, basically we are saying how many plants are there per unit area. How many plants are there per unit area? That one, we call it density of planting. So we can also have what we call tillage studies. So tillage studies, you know, there are different types of tillages that can be used. CA, conventional tillage, we have ridge, we have furrow. So we may also try and check which tillage type will produce the highest yield. Factors are often interactive. I think we will understand the issue of interactive as we move on. So it is good to include combination of multiple factors, levels of 2 or more factors. So obviously plot size is larger due to machinery and border effects. So that is so we need to include a number of factors so that we can see in combination how will a dependent variable respond to the combination of factors rather than just one isolated factor. So we also have integrated pest management. I'm sure you have done entomology, or you are yet to do entomology, the study of pests. So there could be some experiments that deal with weeds, disease, insects, nematodes, and so forth. So we might want to see the complex interactions between pests and host plants, mobility and short generation time of pests often create challenges in measuring treatment response. So studies of pests are critical because we know that if we don't understand the weeds, the disease, insects, and so forth, that can reduce yield so much, despite how good our agronomic practices could be. If we ignore the pest management, we need to make sure we manage pests and we put them under control so that we maintain acceptable yield levels. Now, we also have plant breeding trials. Often these trials include a large number of treatments, which we have a special name that we use in breeding, genotypes. So we can try a number of varieties in a particular place in order to see adaptability and stability of those varieties. So the varieties, we normally call them genotypes. In most cases, we may have 10 or 20 or so, and we try them in a particular environment, and we want to see how they perform in that particular environment. Such experiments are most often called breeding trials. Breeders are busy working towards producing adaptable and improved varieties that can continuously improve yield to meet the food demands of the ever-growing population. So now we also have what we call pasture experiments. Initially, you can use clipping to simulate grazing. Ultimate response measured by grazing animals, so plots must be larger. So you see there are a lot of rangeland studies to do with the pasture, where we want to perhaps establish which feed, animal feed, can give a higher weight gain of an animal and perhaps higher production in terms of milk and so forth. So we can carry out such studies. So we also have what we call rotational experiments. So by rotation, I'm sure we all understand crop rotation. You may want to determine effects of crop sequence on target crop or pest, pathogen, or environmental quality. So what happens if I grow tomatoes in a field where initially there were potatoes or onions and so forth? I'm sure we understand the basic principles of crop rotation. So we may also carry out rotational experiments to see how the sequencing of crops affects yield or whatever parameters that we may be interested in. So farming systems research is also another type of field experiments. So these ones, we want to move new agricultural technologies to the farm. A number of farms in the target area are identified. Often 2 large plots are laid out, old versus new. So we can should be located close enough for side-by-side comparison. May include best bet, combination of several new technologies, recent emphasis on farmer participation in both development and assessment of new technologies. So if for example, we come up with a new machinery or equipment and we want to test that machinery, we need to use the old machinery that we know for sure how it performs, that we call it perhaps our control treatment. Then we have the new machinery, which is also tested side by side with the old. So that one is always done in order to introduce new agriculture technologies. Now, I want us to appreciate the fact that when we do an experiment, there are errors. But we want to understand the errors in field experiments, the natural sources. We call them natural because these ones, they come naturally. Now, we have what we call plant variability. Type of plant, larger variation among larger plants. Competition, variation among closed-spaced plants is smaller. Plot-to-plot variation because of plot location, which we call border effects. So that is the... Then we also have the seasonal variability. That is the climatic differences from year to year, rodent, insects, and disease damage. Conduct tests for several years before drawing firm conclusions. So there are variations or sources of error due to seasons and also sources of error due to plant. We also have the sources of error which are attributed to soil variability. differences in texture, depth, soil holding capacity, drainage, available nutrients. So you would realize that plants in the same field, they may actually differ. Plants from the same type of variety, planted the same day, but in the same field, they may be different in terms of the size of their plants or whatever, because of variation due to texture, depth, moisture holding capacity, which is always defined due to distance along the land, the farming land. Now, I want us to talk briefly about precision agriculture. Techniques, technologies, and management strategies that address within field variability of parameters that affect crop growth. So we have those techniques where we are, or management strategies that try to address within field variability of parameters. So those techniques, they try to address issues to do with the soil type, soil organic matter, plant nutrient levels, topography, water availability, weeds, and insects. All those techniques, we call them, or it's an attempt to improve precision in agriculture. Now, how do we design an experiment? So basically, I have some stages that can be used to design an experiment. You state the problem. There must be formulate hypothesis, set up a controlled experiment, record results from your controlled. What are you controlling? Control your treatments, measure the dependent variable, and then record your results, analyze the results, draw conclusion, publish the results, submit your findings to your department, submit your findings to the nation, and let the nation consume the results. So those are the basic steps in designing an experiment. You must have a problem. You form a hypothesis that should guide the process of addressing the problem. You set up a controlled experiment where you go to the field, you lay down your experiment and so forth, record the results from your experiment, analyze the results, and then finally draw conclusions. So as you set up your experiments, you do realize that you must be cognizant of the different types of variables. There is what we call continuous variables. Now, these are variables that can take on any value within a given range. For example, height can be, the 0.3, 0. Whatever. It can take any value. But we also have what we call discrete. These ones, they take exact values. For example, the number of cars passing through a particular point. We cannot say we have 2.3 cars passing through a point. It's either 1, 2, 3, 0, 1, 2, 3, and so forth. So we call such a variable discrete. Then we've got categorical, which can be qualitative, no natural order. We don't have order. For example, we can say the religion, where we can have the Muslims, Christians, those who follow the African traditional religion and so forth. Those are categorical. They have no natural order whatsoever. So I think here I just try to reinforce, but I think perhaps we have already covered this. Experimental procedure, when comparing the treatments or factor level, means you begin by stating the objectives. This is very, very important. You have a problem, but you need to state the objectives. What do you want to achieve? Then you go on to collect data. You analyze your data in line of the stated objectives. Objectives tell us what measurements are to be made, how, when, and where, and on what. That is very, very important. Now you can consider the following example. Compare the mean weight gains of steers that are fed diet A and B. So compare the mean weight gains of 2-year-old Holstein steers that are fed diets A and B for 6 months. Now here I just gave a flow of the steps in experimentation, which I've already given. Define the problem, state the objectives, select your treatments, select your experimental material, select of experimental design. We are going to look at the different types of designs so that you understand what experimental design is. But the other ones, I think I've defined them. Selection of the unit for observation and the number of replications. We are going to look at these things. Control of the effects of the adjacent units on each other. Consideration of data to be collected. What data are we going to need? That must also be guided by the objectives that you seek to address. Consideration of data to be collected. Outline statistical analysis and summarization of results. Of course, this must be guided by literature, how other researchers have answered similar research problems. Then conduct the experiment, analyze data and interpret your results. Preparation of a complete, readable and correct report. So a well-planned experiment must be simple. It must have high precision. It must be free from systematic error. It must have a wider range of validity, well-defined reference population. Repeat the experiment in time and space in order to validate your results. So it must have a combination, quite a number of or a set of treatments, also meant to increase the range. So I think this one we've already covered. Maybe as an exercise, suppose we wish to compare the mean nicotine content of 3 brands of cigarettes, namely Kingsgate, Madison and Everest. These are just different types of cigarettes. I'm sure those who smokes, they do understand what I'm talking about. So suppose we want to compare the mean nicotine content. We will analyze 10 cigarettes of each brand for nicotine content and record the amount of nicotine in each cigarette in milligrams. So what is the response variable? Identify the factor we wish to study. What are the factor levels of the factor? Identify the experimental units. Ladies and gentlemen, this is an introductory video to experimental design. And I want us to bear in mind that whatever research we are going to do, is either we are going to go into the field and collect data by asking people, maybe through a survey or so, or we are going to lay down an experiment where we control certain factors and we may allow other factors to then respond to those factors that we are controlling, in which case that is called experimental design. So I've introduced the different terminologies. Let me, for clarity, emphasize the fact that you need at this point be in a position to define what an experimental design is, what is an experimental unit, what is a treatment, what is a factor. That is very, very important. And of course, response variable or dependent variable, what is an independent variable, and so forth. Thank you very much, ladies and gentlemen. We are going to meet in the next video, in which we are going to then proceed to introduce what we call principles of experimental design. Thank you so much.